If Interstellar Visitor 3I Atlas is a comet, we can definitely say, if you think that comets always behave like the pictures in the textbooks, this one definitely taught us that it does not, if it is a comet, because it has so many anomalies that nobody seems to be able to explain. And I just reported another one yesterday. And that is so interesting because the new images that we got from NASA, they were hoping that these images and spectrographs would explain the mysterious anti-tail and all that stuff that comes with it. But it just added another anomaly. And now, guys, we do have new Hubble images from January 14th. And guys, what can I say? Listen, just listen to the new observations. It is still highly interesting. The newest Hubble images of interstellar objects 3I Atlas, something shows up that looks almost, I have to say it, engineered. It looks engineered. There's no other way to describe it. It's not because we're like jumping to like aliens, but the geometry. Because of the geometry of what Hubble sees, it's so strangely orderly that it really forces a serious question. We've talked about the geometry in previous videos, but guys, look at these images, right? But back to my serious question that I wanted to answer. Why would a natural object eject material in a pattern that looks like a sunward anti-tail plus 3 evenly spaced mini jets? We talked about the angles that are like the same. Is this a natural chaotic comet? Normally comets are chaotic and the jets are like everywhere if they are there. So mini jets that are like as if they were placed there by a pattern. And none of them is doing the normal comet tail thing. I want to combine 2 new observations today in one video, the new images, but we also have to talk about that wobbling tail again, that rotation. We talked about this in previous videos. If you have seen all my other videos, you know what I'm talking about. If you want to look more in depth at everything, guys, check out my playlist. I'm going through every single anomaly, has its own video. I'm going through the probabilities of each anomaly happening in a normal comet, and then added together that all of them are happening in a normal comet. And I can tell you it's zero. And guys, since we're at it, please, thank you so much for doing this. Guys, you rock. Can you leave this video an early like and hype and leave a comment, share it with your friends. It helps my channel and it doesn't cost you anything. Okay, guys, I want to answer, no, I can't answer that question. I want to tell you the question that comes to mind. Why would this natural object eject material in this pattern, like the 3 jets and the anti-tail? So the weird jet geometry that we see in the new Hubble image from January 14th, 2026. And then we have the finding that 3I Atlas rotates on a 7.1 hour cycle after it came out of perihelion, and that is based on 2 independent measurements. We'll get to this. And I really try to explain the technical terms in a simple language because they are important. You need to understand them. You need to get a picture of what's happening, because if you have that picture, then suddenly the weirdness becomes crystal clear. It becomes crystal clear, guys. So what did Hubble actually see just 3 days ago, or 4 days ago, January 14th, 2026? And it's unsettling. And here's why. First, the basics. Hubble took 6 exposures of 3I Atlas on January 14th, 2026, each 170 seconds long. They have used a camera system that is called WFC3 UVIS with a broad filter of f350LP. That is for the ones that are interested in that stuff. So if we look at the raw brightness map, you see a glowing halo around the object. We talked about the halo yesterday when the new NASA images were coming out. So the halo is called coma in comet language. So coma, think of this as a foggy envelope of like dust and gas around the central core. In these Hubble images, that glow extends to at least 130,000 kilometers. That's roughly 100,000 miles towards the sun. This is huge, extraordinary long. Basically, that's roughly a third of the Earth-Moon distance. That's how long this is, guys. And here's the trick. Listen to this. That coma glow is mostly circularly symmetric. Okay, what does that mean? It's like a soft flashlight beam around the center. So what does that do? It hides the finer structures of interstellar object 3I Atlas. So they processed the images and they were using a filter called the Larsen-Sekanina rotational gradient filter. I'll translate that in plain English. This is basically just saying, let's mathematically subtract the smooth round glow so that the faint directional features, these three jets, pop up. It's hiding them. You can't see them. It is what it is, right? So they pop out with this filter. Gosh, guys, and when they do, you don't just see a tail. I mean, see it for yourself. It's right here behind me. You see 4 jets, don't you? 4 jets. Prominent anti-tail that's towards the sun. We've discussed this at length in my last video. 3 mini jets spaced like the points of a triangle 120 degrees apart. That is strange. Why is this so precise? And then guys, here's the punchline that I have to give you. None of these mini jets points away from the sun. Boof, there it is. It does not point away from the sun, which they should. How can you be so perfectly aligned and you're not even pointing away from the sun? You're withstanding these solar winds. A normal comet tail gets pushed outwards. No discussion. That's what's normal. So now, guys, you're sitting at home, you're viewing what I'm saying, right? So you're probably asking, well, wait, aren't comets supposed to blow away from the sun? Yes, most often. But 3I Atlas keeps showing this absolutely stubborn, sunward directed, I call it structure, anti-tail. And it's not subtle. It's like huge, prominent, and anomalous. And anti-tail, it's not just like a cute word for what we're seeing here, guys. This is a physics problem. It's breaking physics. Let's look at the sun a little bit, right? We know the space environment near the sun, it's not calm. You have a solar wind, that's a stream of charged particles that's flowing outwards, and we have solar radiation pressure. That is basically light itself pushing on small dust grains. This is what we're getting from the sun. Both effects generally, they push dust and gas away from the sun. We learned yesterday the particles that are coming off of 3I Atlas. They're not the fine particles that we usually have that can be pushed away. They're way bigger. So, Harvard professor Avi Loeb, he's the only one that really gets into these anomalies and is looking for answers. I quote him. He has a blunt question that he just asked when he saw these images. And he said, quote, "How can this anti-tail penetrate hundreds of thousands of kilometers sunwards without being deflected away, like familiar comet tails usually are? How can it?" Yes, big questions. So the explanations that he lays out make absolute sense for what the anti-tail might actually be made of. could be made of fragments of ice, large dust grains, we've discussed this in my last video, big enough so that radiation pressure from the sun doesn't shove them around as easily, or even massive objects. That's number 3, massive objects. And he has mentioned in prior work, right? What could these massive objects be? So you don't have to agree with any particular option of these 3 to recognize the core issue that stands out in all 3 questions or options. In order for 3i Atlas to be able to keep his anti-tail, or this structure, aimed towards the sun for such a long time and for that far, 100,000 miles, you need particles that are either big, heavy, unusual, or being produced in an odd geometry. I think they are produced in an odd geometry. We see it. Very odd. The geometry is exactly what looks strange in the January 14th processed images. A clean system of 3 mini-jets, evenly separated. Boof! Explain this, NASA. I have to say it again, guys. The mystery remains. Timing matters, guys. Timing matters. The wobble of the jets, half-hour window, and the 7.1-hour wobble. What am I talking about? Watch the connection. January 14th, 6 Hubble exposures span about half an hour from first to last exposure. So Avi Loeb, together with Tony Scarmato, they have done analysis of earlier Hubble images that we have seen from December 2025, and they have concluded that the jet structure, the wobbles periodically by about plus minus 20 degrees over a period of roughly 7.1 hours. We talked about this. So if the jet system is in a 7.1 hour cycle, then over 30 minutes of looking at it, exposure, you'd expect only a modest rotation in the jet orientation, right? Because it takes 7.1 hours to rotate around its own axis. So that would be a 5.6 degree shift over that half hour. You can do the math, right? So what does that mean? The weird geometry that has been now documented and seen on the January 14th images is not just a blur or like one accidental frame. It is a stable looking configuration within the expected motion. And we have 2 independent measurements regarding the 7.1 hour rotation, and we have the same answer each time. First, question asked, did 3i Atlas change its rotation during perihelion? Is something different when it came out of perihelion? That's the moment when it passed closest to the sun on October 29th, 2025. So 2 ways they measured the rotation. Method number 1, they have tracked the jet direction over time. If the object is rotating and its jet source is tied to the rotating body, the jet direction on the sky shifts in a repeatable cycle, right? If it rotates. So they have measured the position angle of an anti-sunward jet. They have used the Hubble images from November 20th to December 27th, and they have processed it with the same Larsen-Sekanina filter. Position angle, just to tell you, by the way, that is just the direction the jet points on the sky, measured in degrees with a standard astronomy convention. So method B to look at this and investigate it. Measure the brightness pulse over time. So separate from the first method, they have used data from a 0.25 meter telescope, the MPCL-92 in Calabria in Italy. So they have looked at the brightness changes between December 9th and December 22nd. What did they get? they got a jet wobble cycle of 7.2 plus minus 0.05 hours. Brightness variability 7.136 plus minus 0.001 hours. Slightly different, but close enough that they attribute the difference to practical issues like systematics and aliasing, like basically measuring artifacts and sampling effects. So it has to do with their measuring methods. So it is the same if we subtract that. So the bottom line is post-perihelion rotation is about 7.1 hours, and this rotation is linked to a precession of the jet structure. Precession means instead of pointing in a fixed direction, the jet direction slowly sweeps around like a wobbling, spinning top. How can it do that? Well, we also have an alignment problem. Interesting point that is related to this. Why is it that 3I Atlas's spin axis is pointed near the sun's direction? This is basically one of the most like, hey, wait, what? Parts of this whole video, I would say. So what the scientists, especially Avi Loeb and Tony Scamato, infer is that the average position angle of the jet corresponds to the rotation axis direction, around 270 degrees, while the sun to 3I Atlas line is roughly 290 degrees. So they conclude the rotation axis is aligned with the sun object line to within about 20 degrees. That's a long line, guys, right? So it's surprising. It is very surprising. Scientists are baffled because the spin axis should have been set in interstellar space. That interstellar space should have defined the axis long before our sun from our solar system could basically train that axis into alignment. And they go even further. They quantify how unlikely this is if this were just random. They're giving it a probability range of about 1.5 to 6% for such an alignment occurring by chance. And don't forget, this is not the only anomaly. We have probably 20 by now. What are the chances? All of them? So you don't have to treat that as a definitive proof of anything exotic, but it is a legitimate, like, this really needs an explanation flag, I would say. It really does. Can someone give us just an explanation, right? So are these brightness pulses coming from the nuclear surface? Probably not. This is also interesting. Let's push back on a simpler idea. Maybe the brightness variation is just sunlight reflecting off the rotating solid core of 3I Atlas. So Avi Loeb has a thesis. He says, after perihelion, less than 1% of the scattered sunlight came from the nuclear surface in earlier Hubble images, like the July 21st image 2025, when they first discovered it. And that near perihelion, the mass loss rate has increased. So the brightness changes by tens of percent must come from the glowing material around the nucleus, not the solid body itself. That's the explanation. So, but if that's the case, how does the rotation cause brightness changes then? Because as the object rotates, the jet's outflow direction sweeps around, changing things like how much dust lies along our line of sight where we see it, how the dust sits inside the measurement cycle, the aperture, and how the dust scatters light at the viewing angle. And this is interesting what Avi Loeb says, because he uses a memorable metaphor. He says the jet's The jets are pumping dust and gas into the coma like a heartbeat. That means regular. Boof, boof, boof. Is that a natural comet? Guys, you be the judge of that. But we have to look at that before versus after perihelion again. Why the clock might change in brightness but not in the wobble. So the jet precession period after perihelion, roughly 7.2 hours, 7.1 something, is consistent with a pre-perihelion jet precession estimate of 7.74 hours within these uncertainties that we mentioned. But earlier brightness-based rotation estimates, I reported about this, before perihelion were longer, 16 to 17 hours. And the mismatch could have happened because perihelion changed the number of jets or active regions. The number of jets has changed. So is this a simple physical picture? Before perihelion, maybe only one pole region of 3I Atlas was illuminated. After perihelion, the other pole also becomes illuminated, potentially producing 2 active jets. Okay, we have 2, which definitely can make the brightness pattern appear to like repeat more often. So the object could keep a similar underlying rotational state, but the visible modulation changes because the activity pattern changed. But we don't know. And that's why I reported we're waiting for an important time frame from January 19th to January 26th. January 19th, that's coming up. But within that time frame, January 22nd is the date, because this matters so much. On January 22nd, Earth will be aligned within only 0.69 degrees of the line that connects Atlas to the sun. They will be on one line. You can draw a straight line between them, Earth, Atlas, and sun. It's basically a near perfect opposition geometry. Check my last video, one of my last videos. I'll explain it in very detail because this is absolutely important. The Earth is between the sun and 3I Atlas. Opposition. That's why it says that. So we see the object, 3I Atlas, more fully illuminated. Similar basically to how a full moon is brightest when it's opposite the sun in our sky, right? And we will be observing it from the sun's direction. And the sunward anti-tail could be pointed more directly towards us here on Earth, while the anti-sunward jet may nearly disappear from our view. It may. So if we then do measurements of the brightness surge and the polarization at opposition, that could help us to determine what the anti-tail fragments really are, composition of them, and size. I mentioned polarization, right? We want to find out the brightness surge and the polarization. Polarization is basically a property of light that changes depending on what the light reflects from. Does it reflect from tiny grains, from bigger grains versus surfaces? So it's a clue about the particle size of the tail and the makeup, basically. But guys, now the weird jet geometry, we have an important chemical clue. We talked about the chemicals on 3I Atlas yesterday and how we can see them in different images that are also new, the SPHEREx images. And that's a weird geometry, very, very weird. So the SpaceX data, in my last video, I reported about this. They indicated icy fragments around 3I Atlas before perihelion. But after perihelion, in December 2025, the spectral signature of ice has completely disappeared, and instead, NASA's SPHEREx saw an abundant gas phase like organic molecules, and listed in their images as example CH3OH, H2CO, CH4, C2H6, plus about 20 times the increase in water production rate. So the jets and the water production rate, that's a huge anomaly. And the long time scale, like being interstellar, is important to survive like a cosmic ray bombardment over an interstellar journey that 3I Atlas has done, lasting like billions of years. Those organics would need to be buried under a protective, like a thick protective layer that is at least like 3 to 4 feet deep, like 10 meters. So you get a picture like this. Something about perihelion may have stripped or changed the surface layers on 3I Atlas, exposing or releasing different materials that were on there. But the jet geometry and the antitail behavior, highly, highly unusual. So we have exciting weeks in front of us to analyze more data to really, really find out what this is. Stay with me, guys. Subscribe. Thank you so much for giving it the like and the hype. And well, leave me a comment. What do you think it is? What is it? What do you think it is? And well, click one of the videos in the end screen. I have a huge playlist of 3I Atlas if you want to learn more about that. But there's stuff going on in the Philippines. The military is getting active because we have a huge danger from dangerous lahars. They're hot. They burn everything in their way. Why do they do this? We have a volcano erupting that is just preparing maybe for a huge eruption, and then we've got a typhoon coming on these steep slopes of that volcano. Watch the video on the end screen. Any of them here, then I see you in a second. Thank you, guys. Bye-bye.